Hello everyone, welcome to Gate Forum, and today we will start our lecture number 4 in this video series on YouTube channel, that is on Gate Forum YouTube channel. And here in this lecture number 4 I will be discussing this topic Mohr circle, very important topic, that is principal stress and strain, very important topic, very important topic, because so many questions we have in the previous Gate year question papers from this topic Mohr, or I can say 100% guarantee of one question. I can say 100% chance of one question from this topic in your GATE examination. Suppose if you are going to appear in the next GATE exam, that is GATE 2025 or GATE 026, definitely one question 100% in GATE examination from this chapter, that is Mohr circle. So very important. Okay, so let's start the video, and this video will be helpful for both mechanical engineering as well as civil engineering student in the GATE examination. Okay, let's start. So first we will go for the 1D or uniaxial stress system. Suppose here we have one rod or one bar, whatever you call it. Okay, here we have one rod or one bar like this only. And suppose if we are interested to find the value of stress, if we are interested to find the value of stress, suppose load is applied here P axially. Only in one direction we have load. That's why it is known as 1D. That's why it is known as 1D or uniaxial stress system. 1D or uniaxial stress system here we have. Now what happened here, generally we used to find out the value stress on this transverse plane, because this plane is known as transverse plane. This one is known as transverse plane. Here we have the plane which is perpendicular to the axial plane, and this plane is known as axis of cylinder or axis of rod. So this one is known as axial plane. This one is known as axial plane. Here we have axial plane. Here we have, and perpendicular to this axial plane, here we have transverse plane. Here we have transverse plane which is perpendicular to the axis of the rod, perpendicular to axis of rod here. And we can have different planes also here. So on transverse plane, what happens? Suppose if somebody is asking what is the value of stress, you will say, okay sir, here we have external force P, and on this transverse plane you have to take section here on this transverse plane. So here we have restoring force or resisting force R, and stress on this plane, normal stress on this plane will be resisting force per unit area, and which is equal to P by A, force per unit, like this only on this plane transverse plane. On this plane transverse plane, this will be the condition. But what about shear on this plane, sir? What about shear tau? So there will be no shear on this plane. There will be no shear on this plane. So this transverse plane having only normal stress. Only normal stress. So normal stress here we have, only normal stress on this transverse plane here we have, which is sigma, which is equal to P by A, sigma which is equal to P by A. But if we go for the shear stress, on this transverse plane, so definitely you will say there will be no shear stress, tau will be 0, because there is no resisting force parallel to the area. There is no resisting force parallel to that area, parallel to that cross section area. Okay. But suppose here we have one problem. But suppose if here we have one problem like this, or one question like this, here we have load is applied in this direction, 1D only, not 2D. Here load is applied in one direction only, and suppose plane will be like this, and suppose plane will be like this, then what I can say? Suppose plane will be like this, then what I can say? The plane is known as oblique plane. The plane is known as, first of all, oblique plane with some orientation or with some angle, theta, and theta can be from 0 degree to 90 degree, 0 degree to 90 degree, 0 degree to 90 degree, or 0 to 180 degree, 0 to 180 degree I can say, 0 to 180 degree, yes or no? Yes, definitely 0 to 180 degree I can say. Okay, now here theta can be, so location of plane changes if theta changes, location of plane changes theta. So oblique plane will be with some angle theta. And what about here for transverse plane? What about for transverse plane? Here we have, so for transverse plane here we have theta is equal to how much? Theta equal to 0 degree here. Theta is equal to 0 degree. Theta equal to 0 degree here we have. And for axial plane here, what is theta? So here we have theta 90 degree. Theta is equal to 90 degree only. Okay, theta here we have 90 degree. And for any oblique plane, theta can be in between 0 to 180 degree like this one. 0 to 180 degree only. Okay. So for any oblique plane, we have stress value on this oblique plane. We have stress value. I'm writing on the next page. So please try to remember the formula. In the paid courses, already I'm telling to you student that this is not a full course or paid course. This video is on YouTube channel, Gate Forum YouTube channel, and I am providing you series of videos on this subject, strength of material. On strength of material, series of video series is provided on this YouTube channel to help you out, but this is not a full course or paid course. That's why so many derivations not done in this class. I'm providing you just idea, important formula like this only, so that you can watch videos, you can take help from the video, you can start your journey for your coming gate examination, that is your gate 2025 as well as gate 2026. Okay, so in this video we are just showing you how good we can teach, how good we can train you for a gate examination. I am also from IIT Kharagpur. I have cleared my gate examination, then I have done my MTech and PhD from IIT Kharagpur. So, and I have taught so many years. I have experience of so many years. I have got almost 10 years experience, 10 to 12 years. And I have analyzed all the 32 years question paper of gate examination, previous year papers, so that I can give you some guidance that which topic has very good importance in gate examination, which topic derivation is very important, which topic derivation is not so important. But since this is not a full course, so we are not doing unnecessary derivations. I am providing just good concepts and in very crisp way, in very short duration. Okay. So here what happened? Suppose here we have 1D condition. Here suppose here we have rod and one load is applied here P. One load is applied here P and cross section area is A. Cross section area A. And suppose if here we have plane, and suppose if here we have a plane, and on this plane we need to find out this plane having some orientation theta. This plane having some orientation theta like this. Here we have theta, angle is theta here we have. So what happened? What is the value of normal stress on this plane and what is the value of shear stress on this plane, on this transverse plane? So normal stress will be P by A, load upon area P by A multiplied by cos square theta, and shear stress will be equal to P by 2A multiplied by sine 2 theta. So depending on the value of theta on the different planes, we have different normal stress value as well as we have different shear stress value, as well as we have different shear stress value. So please remember these two formula, very important formula for 1D. Only these two formula in 1D we have only these two formula. So very important formula, very simple formula, P by A cos square theta and P by 2A sin 2 theta. Okay. Suppose somebody is saying on transverse plane, what will happen? If suppose somebody is saying on transverse plane, if here we have a rod and load is applied here in the axial direction, load is here, we have P in the axial direction, and somebody is saying what happened to the transverse plane, what happened to transverse, what is the value of theta here? So definitely we say theta equal to 0 degree for this. If theta 0, put the value of theta equal to 0. Put theta equal to 0 in the above two formula. What will the value of sigma and what will be the value of tau? Putting 0, cos 0 will become 1, so this will become P by A. And what about sine 0? It will become 0, so this will become 0. So on transverse plane we have sigma is equal to P by A, but tau equal to 0. Already in the last page I have told you. Okay, so 1D stress system here, very simple 1D stress system. I have covered 1D stress system, and now I will move to 2D. 2D stress system. Okay, so now moving to the 2D or biaxial or plane stress system, or either we can call it as 2D or we can call it as biaxial, 2D or biaxial or plane stress system, or plane 2D stress system or biaxial stress system or planar or plane stress system. Okay, so what happens generally in 2D, we don't have a stress only in the one direction, but we have normal stress in the two directions. Suppose here we have sigma x, okay, and here we have sigma y in the y direction, here we have sigma y here we have and here we have tau xy also. Here we have tau xy, that is the shear stresses, tau xy here we have. Here we have shear stresses, tau xy. Here we have tau xy or tau ix. Okay. So sigma x will be given to you. Let's say sigma x will be given to you just 100 value. Sigma y is given to you, let's say 60 value. Sig tau is given to you, let's say 30 value like this one. Let's say 30 will like this one. So values will be given to you. That means in exam, sigma x will be given to you, sigma y will be given to you, and tau xy will be given to you. Generally, these three value will be given to you. Okay, these three value will be given to you, and generally you need to find out. Generally, you need to find out. Okay, the value of stresses on the different planes. Okay, and normal stress, shear stress, as well as principal stresses. Okay, now what happened if I go for Mohr circle? If I go for Mohr circle, only simple step to draw the Mohr circle. Suppose steps to draw the Mohr circle, please learn here, steps to draw any Mohr circle only in two steps. Steps to draw Mohr circle. Steps to draw Mohr circle. Steps to draw Mohr circle. So if we are going for steps to draw the Mohr circle, so first step is to write the coordinate. Write the coordinate of two plane A and plane B. Plane A and plane B. Write the coordinate of two planes. Okay, I'm writing the coordinate of two planes. Just look at here. Suppose here we have two plane like this. Suppose here we have two plane like this. One is this horizontal plane and another one is vertical plane. Vertical plane name is, let's say, A, and horizontal plane name is, let's say, B. Let's say B here for horizontal here. So what is the value of stress on this vertical plane? On this vertical plane here we have sigma, which is 100, sigma x, which is 100 here. So I can say 100 comma this value at this center. This will turn this. This will turn, just look at here, this tau xy 30 will turn in counterclockwise like this. This turn in the counterclockwise direction, which is negative, So 100 comma minus 30, 100 comma minus 30 here we have. What about B? So here we are writing 100 comma minus 30, 100 comma minus 30, or we can write in this way also, sigma x comma minus tau xy, like this only. What about for B? Sigma y, here we have sigma y, that is 60 and plus 30, 60 plus 60 and plus 30 like this only. Because why plus 30? Because just look at here, for the sign convention of tau on this plane, on this B plane, what happened? This tau xy will be rotating like this. That is the clockwise. Which is positive. Here. First of all, so what is the step number one? Just write the coordinate of 2 points A and B. After writing the coordinate, what you will do? You will just make one x-axis as well as one y-axis. X-axis means sigma normal stress, y-axis means tau shear stress. And here somewhere here we have origin. Plot these 2 point A and B. Suppose I am plotting this point A 100 comma minus 30. Somewhere here 100 comma minus 30, point A is plotted here. I am plotting point B 60 comma plus 30. 60 comma plus 30, here we have plotted point B here. So first of all, write the coordinate of two perpendicular planes first of all. Second thing, plot the 2 points on sigma versus tau graph. And third thing, join this AB line. This will cut x-axis at the center of Mohr circle, and these two will become radius. And with center radius, you can draw the circle, and this will become Mohr circle. So here we have only very two simple steps to draw any Mohr circle. So this will become Mohr circle. This will become Mohr circle. So very simple step to draw any Mohr circle. Only two steps and nothing else. Just write the coordinate of two perpendicular planes, then plot the 2 points on sigma versus tau graph, then join that 2 point with the line which cut the x-axis at the center of Mohr circle, and from center to the circumference just draw the circle. This will be Mohr circle. Very simple step to draw any type of Mohr circle. If any teacher is saying another method to draw this type of stress, another method to draw this type of stress, another method to draw for Mohr circle, no. For any type of question, only these two steps, only single method, only just do these 2 steps to draw Mohr circle for any type of problem. Okay, very simple. So we have seen how to draw the Mohr circle. Now we come to know. Now we will calculate that what is the value of center, what is the value of radius of this circle. Where we will have center of this circle, what will be the value or magnitude of the radius of the circle, we will come to know. So what about center of the circle? If we go for the center, na, we will go for the center of the Mohr circle. Suppose here we have a circle, suppose here we have circle. So where is the center and what is the value of radius? And what is the value of radius here we have? So center will be always on center sigma x plus sigma y divided by 2 comma 0. Center will be always on the x-axis. Center will be always on the x-axis here on the sigma axis like this. And what about radius? What about radius? So radius will be sigma x minus sigma y by 2 square plus tau xy square plus tau xy square. This will be the value of radius. So please remember the formula of center radius. So many times asked in mechanical and civil in the previous PYQ. In the PYQ previous year question paper, we have so many questions from center as well as radius first of all. And now then we have a principal stresses, then we have a principal stresses, then we have a principal stresses, that is sigma 1 and sigma 2. So sigma 1 is known as center plus radius and sigma 2 is known as center minus radius. Center minus radius and center plus radius like this only. If somebody is saying write the value of sigma 1, write the value of sigma, definitely you can write. So what is sigma 1? So what is sigma 1 into, I'm writing 1 into, right, in one formula only. What is center? That is sigma x plus sigma y divided by 2, center distance, plus minus both signs simultaneously, for plus sign for sigma 1, minus sign for sigma 2. Under root, here we have sigma x minus sigma y divided by 2 square plus tau xy square plus tau xy square like this only. So here we have sigma 1 2, that is principal stresses. So sigma 1 is known as major principal stress, major principal stress here we have, and sigma 2 is known as minor principal, because this one is smallest one, so minor principal stress here we have. The smallest one will be the minor principal stress and largest one will be the major principal stress. Major. On this Mohr circle I will be showing you sigma 1. So this point, the last point here we have maximum normal stress is the sigma 1. Maximum normal stress is the value of sigma 1 and minimum normal stress is the value of sigma 2. Minimum normal stress is the value of sigma 2. So what is the value of dia of the circle? What is the value of the dia of circle? Diameter of circle, which is sigma 1 minus sigma 2, which is sigma 1 minus sigma 2. So what about radius? Radius will be diameter by 2. So sigma 1 minus sigma 2 divided by 2. So this will become radius of this circle. This will become radius. So diameter as well as radius. And this is also formula of radius. This is also formula of radius. Okay, this is also formula of radius here we have. So if you are knowing the radius, either from this formula we are knowing the radius or from this formula we are knowing the radius. If somebody will ask what is the value of tau max, what is the value of tau max? Maximum shear stress. So maximum shear stress is nothing but equal to the radius only. Maximum shear stress is nothing but always equal to radius only. Whatever the value of radius, whether sigma 1 minus sigma 2 by 2 or whether by using this formula under root sigma x minus sigma by 2 whole square plus tau x square. Just find out the value of radius and that will be equal to maximum shear stress inside the body. That will be equal to maximum shear stress inside the body. Very simple. Maximum shear stress inside the body here we have. Very simply we can write. Very simply we can write here. So we have a center formula, we have radius formula, we have diameter formula, and we have sigma 1 formula, we have sigma 2 formula, and we have tau max formula, So definitely so many questions in the PYQ, previous year gate question from this topic, and definitely very simply we can able to solve. Very simply, very simply we can able to solve the problems. Okay. Now moving ahead. So we can solve by Mohr circle also, we can solve by direct formula also. Okay, now suppose if I am interested for location of principal planes. So location of principal planes can be also done. Where is principal plane? Here we have, just look at here. Suppose here we have Mohr circle like this. Suppose here we have Mohr circle like this. Suppose here this one is any body, and corresponding to this body, okay, suppose this is the plane A. This is the plane A here we have. This is the plane A here we have. And this is the plane B here we have. After loading, this is the plane B here we have. And Mohr circle will be like this. And Mohr circle will be like this. Just look at here. Mohr circle like this. Plane A will be plotted here and plane B will be plotted here. Plane B will be plotted here. And if we join these two, somewhere here we have center of the circle, and these two will become radius. These two will become radius. Okay. So this is sigma 1 plane of sigma 1. This is plane of sigma 1, that is major principal plane. This one is major PP, I'm writing short form principal plane. Principal plane short form writing PP, principal planes here. Major, and this plane for sigma 2, this one is minor principal plane. Here we have minor principal plane here we have. Minor principal plane here we have. So definitely if you are finding these two values, 2 theta, suppose you are getting the value 2 theta, 2 theta 1, 2 theta 1. So theta 1 will be, theta 1 will be the one with the location of, theta 1 will be the location of major principal plane. Major principal plane, and suppose if somebody is saying what is the location of theta 2, what is theta 2? Theta 2. So theta 2 is nothing but whatever the value of theta 1 plus 90 only. Plus 90 will be the location of minor principal plane. Very simply we can able to solve. Very simple. Just school level mathematics. Just find out, just use sine theta, cos theta, tan theta, use the circle, and very simply you can able to find out. Very simply you can able to find out the value of theta 1 as well as theta 2. That is the location of the principal planes. Location of principal planes, very simply you can able to find out. Okay, now location is done. Now suppose if I am interested to draw the Mohr circle, suppose if I am interested to draw the Mohr circle for 1D, Mohr circle for 1D, suppose if I am writing Mohr circle for 1D, Mohr circle for 1D, Mohr circle for 1D. If I am interested for Mohr circle of 1D, that means if only load is applied only in the one direction. Okay, like this one. Only sigma x here we have. Only sigma x here we have. That means rest 2 will be 0. Sigma y will be suppose 0 and tau xy is also 0. Tau xy is also 0. Rest 2 will be 0 given here. That is 1D. This one is known as 1D. Na? So how we will draw the Mohr circle? How we will draw the Mohr circle? In the same way, just plot. I have taught you the method in today's class only. Just locate. Here we have plane B and here we have plane A. Here we have plane A and here we have plane B. Write the coordinate for the plane A. On plane A only here we have sigma x. Let's say this value is 100. So only 100 comma 0 because there is no tau xy. For plane B, no normal stress, no shear stress. So for plane B here 0 comma 0. For plane B. So how I have taught you how to draw Mohr circle. Sigma versus tau graph here we have first of all. Sigma versus tau graph. Plot the 2 point A and B. Plot the 2 point A and B. Suppose I am plotting A here. Here point A will be somewhere here 100 comma 0 and point B will be somewhere here. Point B will be somewhere here. So AB will be always the diameter of the circle. Here I am showing you here. AB is the diameter. I am showing you here also. AB is the diameter. AB is the diameter. Just look at here. Here plane A. This vertical will be the plane A. This horizontal will be the plane B inside the body at 90 degree inside the body here. Plane A and B. So here we have plane A. Point plane A here we have and plane B here we have. So AB will be always acting as a diameter of the circle. AB is always acting as diameter of circle. Diameter of circle is AB is always acting as diameter of circle. So what I can write here? AB as diameter. AB as diameter simple. Simply AB as diameter only now. So somewhere here midpoint will be the center. Somewhere midpoint center. This will be radius. This will be radius. So here we have circle. So here we have circle like this. This will be Mohr circle. So for 1D, what is the special point? For 1D, a circle will always touch the origin. Circle will always touch 1D. For 1D, circle will always touch origin. Circle, please remember, circle will always touch origin. Circle will always touch origin. So here we have Here we have this Mohr circle for the 1D. We have drawn Mohr circle for 2D also. We have drawn Mohr circle for 1D also. And I have taught you very simplest method and very easiest method, very simple method to draw Mohr circle only in the two steps. Only in the two steps. Just to follow that step only. Just to follow that step only and nothing else. So I hope you have learned this Mohr circle, 1D Mohr circle, 2D Mohr circle, and steps to draw the Mohr circle and formulas also. Definitely it will help you out for your preparation in the coming GATE examination. But once again I'm telling you, this is not a full course. This is not a full course where I'm teaching for 100 hours or 50 hours or 60 hours like this only to complete the syllabus. This video you're watching on the GATEFORUM YouTube channel just for help. So here we have series of video. This video is lecture number 4. Now you can watch lecture number 5 also, lecture number 6 also in the series of strength of material for mechanical civil both. Okay. So please watch this series fully. Please watch this fully, and these are the special cases we will do in the next lecture, lecture number 5. All these topics we will do in lecture number 5. This topic here we have. We will do this topic special cases of Mohr circle. We will do this topic special cases of Mohr circle. Special cases case 1 as well case 2 in the next lecture, which is lecture number 5, which is lecture number 5 of strength of material on the same YouTube channel, GATEFORUM YouTube channel. Okay, so we are here to provide you strength of material series on this YouTube channel. So please watch all these videos of strength of material, whether you are watching lecture number 1, lecture number 2 or lecture number 3, 4, 5 like this only. Watch this whole series so that this can help you out for your coming GATE examination, that is for your GATE 2025 or GATE 2026. And for paid course, definitely you can learn from me on GATEFORUM so that you will get a very good concept. Because here on YouTube I am teaching for half an hour concepts in very crisp, in very short duration. But what happened in paid course or full course, definitely I will be teaching the Mohr circle for continuously for 10 hours, for 12 hours, means in-depth concept and so many questions also. Okay, so I think this video will be very helpful for you. So please like the video, subscribe this YouTube channel and share the video with your friends also. And if you have any query, any doubt, any question in your mind regarding this topic, please put in the comment box of this video. I will be replying you personally. Okay. Okay. So thank you all of you. Bye. We will meet in the next lecture, which is lecture number 5 with the special cases of Mohr. Okay. Bye all of you. Bye.